All right, this is lesson 9.2, which is where we're going to graph projects using the axis of symmetry, y-intercept, and a table of values. So last lesson, we graphed a quadratic like this, except we used an entire table of values. Today, we're going to have a little bit more direction. So do you really have to complete a table every time? No. We're going to find what's called the axis of symmetry and the coordinate of the vertex to help determine where the graph is located. So quick thought about the word symmetry or the word symmetric. This is referring to an image, right? So say like a square, where if you were to draw a line, then this object would be symmetric across that line, where the left and the right side look the same, right? Or you could put like a heart. A heart is symmetric across that line because the left and the right side look exactly the same. A smiley face is also symmetric because if you were to draw this line, again, the left and the right side look exactly the same. So a parabola, which is what we're using this unit, this is symmetric because the left and the right side are going to look exactly the same. So we're going to find the axis of symmetry, which is that line, right? So we're going to be finding this line. And then we're going to find the vertex, which is this point on the line. That's the vertex to determine where the graph is. So axis of symmetry. The axis of symmetry is going to be the equation x equals something, and it's negative b divided by 2a. That should look really familiar because this is part of the quadratic formula, right? Negative b plus or minus the square root of stuff all over 2a, except we're not going to deal with the square root. We'll talk about that later. So it's going to be a line x equals something. So we need to define a, b, and c. A is 1, b is negative 4, c is 5. And we're going to substitute these numbers into this. X equals a negative b divided by 2a. So this equals a positive 4 divided by 2, which equals 2. So we're going to draw the line x equals 2. The line x equals 2 means that the x coordinate is 2, the y coordinate is whatever it wants. The x coordinate is 2, the y coordinate is whatever it wants. The x coordinate is 2, the y coordinate is whatever it wants. So we plot these 2, 0, 2, 5, 2, 7. So in other words, it's a vertical line that passes through x equals 2. So again, this is the axis of symmetry, which means that the left and the right side are going to look exactly the same. So let's find our vertex, vertex being the bottom point or the top point. Now, ignore this for a second. The vertex is always going to be on this line. So we actually know that the x-coordinate of our vertex is going to be 2, because it's either going to be like up here, or it's going to be down there, or it's going to be right here. But either way, the x-coordinate is going to be 2. That's all that means. This means that the x-coordinate is the line of symmetry. Now this part means if we want to find what this value is, we would take 2 and we'd substitute it in. Minus 4 times 2 plus 5. All this means is take the function, so this is the function, and evaluate it at that crazy thing. And evaluate at negative b divided by 2a. That's all that means. So we'll take the axis of symmetry, and then we're going to substitute it in to find the y-coordinate. 4 minus 8 is negative 4. Negative 4 plus 5 is 1. So the vertex is 2, 1. Vertex. Okay. Lastly, we need one point so we know where this graph is going. The easiest point is going to be the y-intercept. So the y-intercept, remember, it always happens when x equals 0. Y-intercepts are always 0, comma something. So we're going to substitute in x equals 0 and solve. So the y-intercept is 0, 5. So we know our graph is going to go from the vertex to that point. Now, we know it's symmetric. So if this point is 2 units away, it's going to be 2 units away on the other side because it's a mirror image. So we use the axis of symmetry to graph the other part. All right, let's do one more example together. I'm going to use all those same things. I'm just not going to refer to them. So we have this equation. We need the axis of symmetry. Axis of symmetry is always going to be x equals, and it's going to be negative b divided by 2a, which we'll solve for. The coordinate of the vertex, it's a coordinate. And so whatever value is here, that's going to go right there because the vertex is on the axis of symmetry. We need our y-intercept, which is always in the form 0, comma, something. So let's do this together. We're going to solve for the axis of symmetry. So we need A, B, and C. A is negative 1, B is 2, C is negative 1. We're going to plug it into negative b divided by 2a, negative b divided by 2a, negative 2 divided by negative 2, which is a positive 1. So the axis of symmetry is 1. So that's a vertical line that goes through x equals 1. The vertex is going to be on this line, so that's x equals 1, and we need to solve for y. So the vertex is going to be at x equals 1, y equals negative 1 squared plus 2 times 1 minus 1. So that's negative 1 plus 2 minus 1. So that's negative 1 plus 2, which is 1. Minus 1 is 0. Vertex is at 1, 0. Lastly, we're going to solve for our y-intercept, which always happens at x equals 0. So y equals negative 0 squared plus 2 times 0 minus 1. 0 plus 0 is 0. 0 minus 1 is negative 1. The y-intercept is negative 1, 0, negative 1. So we know our graph goes from the vertex and towards the point. It's symmetric, so if it's 1 unit away, it's going to be 1 unit away on the other side. And there is our graph. So, a couple important things that I want you to think about. Okay, I answered these questions. I'm just going to review it. So, we solve for the y-intercept. We substitute in 0 for x and solve for y. Why does this give you the y-intercept? Please remember that a y-intercept is will always have an x-coordinate of 0. Because if it's a y-intercept, so if it intercepts this axis, the coordinate will always be 0, comma something. Because it moves left or right, nothing. In regards to the axis of symmetry, so we know the axis of symmetry is x equals negative b over 2a. To solve for the vertex of a quadratic, we substitute that value in and solve for y. So what does the axis of symmetry have to do with the coordinate of the vertex? Remember that the vertex will always be on the axis of symmetry. So here is my axis of symmetry. The vertex will always be on it. So if the axis of symmetry is negative 1, the vertex will be negative 1, comma something. So use that information to help you do the rest of this practice.